Hello everyone, I am Vivanchala. Welcome to my YouTube channel, Space Engine. This is a series of short videos in which I will explain some concepts about the universe. As such, theory of general relativity, dark matter, and particle physics. I will upload every day, so stay tuned. I hope you enjoy.
Today's topic is Mars. Although Mars is nearly geologically dead, it's not completely boring. Close inspection through rovers and orbiters has shown that it has weather. It has a mild hydrological cycle. There clearly has been volcanism. The rovers and objects we left on the surface have shown that there are dust devils and widespread dust storms on occasion. Dendritic river canals, erosion forms that are typical of sedimentation. All of these features together indicate water has flowed some time on the surface of Mars. But it's indirect morphological evidence, and it was not always sufficient to convince planetary scientists that Mars is or even has been a wet planet. The idea is, as with Venus, that Mars was more habitable in the past, particularly 2 to 3 billion years ago. But now, as revealed by the first landers starting in the mid-1970s, the surface is arid and uninteresting looking, just a sea of rocks and dust, more arid even than the worst and barren deserts of the Earth. But the radar reveals that water underneath, and the inventory of the water is truly impressive. Taken as a whole, Mars has enough subsurface glaciers that if they were all melted, they would cover the entire planet with 20 centimeters of water. So while we think Mars is dry and arid, it need not always have the case. We've had orbiters and landers around Mars since the mid-1970s, but the current generation are doing extraordinarily detailed work. Mars orbiters can resolve everything down to the size of a football, and they can map the entire surface, not just in visual light, but in radar, able to detect subsurface water. The small and extremely successful rovers, Spirit and Opportunity, one of which is still doing its work, have been superseded by the Curiosity rover, the size of a small car, just beginning its scientific mission. Curiosity is working slowly and methodically, and has a wonderful suite of instruments, which will give detailed information on the chemical situation and history of the rock it studies. It's important to remember that Curiosity was never built as a life detection experiment. It will not look for DNA or nucleic acids. It will not be able to tell if there are microbes hidden in the rocks. The Viking landers in the mid-1970s and 1960s technology were incredibly impressive, but they could not be sophisticated biological sensing experiments. The landers dug into the few inches of topsoil, put those into the spacecraft, and did simple experiments to heat up the soil, look for what came off, or add nutrients to see if metabolism was at work. While the results were generally either unconvincing or ambiguous, at least one of the experiments returned results that were consistent with the possibility of biological activity. Unto this day, the Pi Gil Levin of the Wolf Trap experiment claims that his experiment may have detected life. Most scientists consider the Vikings not having detected life, but if you read the final report on the missions, the wording is surprisingly ambiguous. Clearly, we need to go back with more sophisticated experiments designed 40 years later and do the work again. An underlying problem or issue is that life on Mars may not be like life on Earth. Its metabolism may operate differently, and they might have different opinions on the planet and how they live. So if we look for purely photosynthetic or similar to Earth organism life, we may fail. In the outer solar system, we have 4 gas giants planets called the Jovian planets: Jupiter, Saturn, Uranus, and Neptune. Although the giant planets are far from the Sun and very cold, the conditions deep in their atmosphere are quite different. They are hot, high temperature, and high pressure, and very strange forms of hydrogen and helium that are very even liquid or crystalline. It's inferred that at the core of each of the gas giants is a rock body several times the mass of the Earth, perhaps 3 to 5 times. The masses of all these rocks are quite uncertain because they are small fractions of the overall mass of the gas giants, and their presence is inferred by the spacecraft passing by. The Voyager missions in the 1970s were the first to explore all the gas giant planets and infer their rocky cores and give us some basic idea of their properties. Each of the gas giant planets has magnetic fields, a diffuse and large ring system, and multiple moons or satellites. A comparative view of the gas giant shows that sizes compared to the Earth. Jupiter and Saturn form a pair, Uranus, Neptune, another pair substantially smaller than the 2 largest planets. These planets, however, may not be harboring life.
Thanks for watching. Please share your thoughts and ideas in the comment section below. Bye.